I'm Dave, and I'm a partner here at AlbionVC.
I'm Seb, and I'm an investor at AlbionVC.
So we're chatting about deep tech today. Yeah. What are the really exciting things that we're seeing at the moment, Seb?
At the moment, I think there's some meta trends, and I think a lot of our theses kind of revolve around identifying those trends and drilling into them quite heavily. So I think there's a ton of obviously really interesting things going on in the novel AI space.
When you say novel AI, what do we mean? I guess there's lots of people investing in Gen AI. Would we call that novel in our definition?
Not in of itself. I think when I think of novel AI, I kind of split it into two broad buckets. Kind of outer distribution, generalization focused AI. So meaning AIs that continuously learn, adapt, change, handle dynamic environments. So that often is robotics, but it's also advanced applications of agents. Just to
train that, so outer distribution is something you can't just train something for with loads of data and it's in that same environment. It's something that's got to take that learning and apply it elsewhere.
Yeah. So, other people speak about reasoning, and there's this big debate about whether LLMs truly reason or if they're just trained on such a volume of data that almost everything is within context. And then I think the other bucket is actually those state-of-the-art models, but how do you then apply them to domains where your expertise is in the other domain? So classic tech bio, materials, engineering. How do you accelerate innovation in adjacent fields?
And we're seeing quite a bit of that, particularly through our UCL Tech Fund, where we are talking to a lot of the academics who are trying to solve the sort of nitty-gritty problems around the edge of, you've got LLMs who are doing cool stuff, but they're still not being applied in industry in some places because of things like hallucinations or inaccuracies or problems with the training data. So I guess you're spending quite a bit of time with those academics, like figuring out which of these solutions are actually going to have an impact and solve some of these problems a bit.
Yeah, exactly. And I think we've seen recently actually with the Nobel Prizes how controversially, or maybe less so depending on your perspective, how AI and machine learning are kind of starting to be applied more widely into other domains. I think one of the strengths and potentially historically weaknesses of universities has actually been how siloed different subject areas are. And I think there's a lot of value to be found if you just get at the intersection of areas. Because, at the end of the day, if you're trained traditionally in ML, you might not know that much about mechanical engineering. And if you're in mechanical engineering, maybe you don't know exactly how you could best apply our state-of-the-art AI approaches to your field.
This is something we were chatting about earlier. There's a movement that says you just drop a bunch of AI scientists into any lab that's already working on something, and maybe they'll be able to help them solve all their problems. Like, how do you feel? I was expressing some skepticism about that, but how do you feel about it?
I think that it's not that simple, right? You can't just drop them in, but I do like the idea that most problems are a pattern recognition problem, and our best approach to pattern recognition on scale is machine learning. So whether that's in understanding the complexity of biology or it's understanding materials, like I think it's directionally probably true that if you can really zero in on how you can apply our state-of-the-art ML models on larger and better curated data sets, that you end up in a better place in those fields.
Yeah, I sort of agree. I think there's part of me that thinks those fields are more complex than just dropping in and doing some pattern recognition. And there's actually, maybe it's my sort of innate belief in human creativity and sort of.
That?
Well, it's when you write something and you don't use ChatGPT. I know that's been a while. But, I guess it'd be interesting to see how. It's going on a lot now. There's a lot of attempts to sort of link up labs with AI scientists coming in to try and do that pattern recognition. I'm intrigued to see how much we really squeeze out of that.
I mean, I think the reality is if you think about like an engineering design process, you want to just accelerate the things that you can automate, and you leave humans to do the creative stuff. So like, your expert in materials will have to lead on a new kind of paradigm or a new experimental topic, but can you take what they've been doing over the last 5 years and can you accelerate those tools and processes so that you can get an exponential increase in their productivity?
Yeah, I think that's probably true. I just don't know whether it in of itself leads to fundamental breakthrough. I think it maybe frees up these top labs and the top minds in it and gives them more insight and data so that they can make those breakthroughs.
Yeah.
But you still need those geniuses at the heart of things, I think.
Yeah, we should put a bet on this.
Yeah. Oh well, I'm sure there's a few people we could talk to at UCL about that. And then across the rest of the kind of AI space, you often get excited with me about the idea of a hippocampus. Are you still sort of playing with that idea?
Yeah, I mean, I use that term very loosely, but obviously a hippocampus is kind of your episodic memory in your brain. I think broadly speaking, I think of kind of your typical LLM or generative AI as akin to your neocortex. So it's a massive unsupervised learning system that's basically just doing coincidence detection on scale. And then you have your reinforcement learning, and that's akin to your kind of VTA and different parts of your brain that leads to a fine-tuning of that system. But, you know, every non-trivial animal has a hippocampus, and it's often used to bring on board new memories. And so that idea of how do you create something that can continuously adapt and change in a dynamic environment, I think we're starting to hit on that. So, you know, there's this recent trend in OpenAI around maybe you can do a smaller model with better search, where search is more akin to hippocampus, and then you don't end up with the need to have a whole bunch of your parameters in your model essentially just be memory. You can leave them to reasoning, and you can rely on search for bringing in novel context. And then the other thing I think is interesting as it relates to that is this idea. There's a recent paper that came out that showed that you can get similar performance to transformer architectures using older approaches. If you can, you know, it required a few tweaks and bigger data sets, but it's this idea that actually maybe it's less about the model architecture itself and it's more about the data and how you engineer a system around that.
That sounds like it poses a problem for startups rather than an opportunity. If it's more about sort of the data and the architecture, which is generally held by the bigger players. Is that fair? Yeah,
I think there's this kind of the reality is incumbents hold data, and data is powerful. Startups, I think, have always won because they've been more agile and they've been able to find a very specific area where they can innovate faster. That's going to remain true. I think this idea of, you know, is there something inherently special about a transformer architecture per se, and is there any moats around LLMs? Is actually maybe a challenge more towards the foundational model providers. Is it a race to the bottom? I think it was A16Z talking about are they just producing rice or something along the lines, in the sense that like you can drop the cost down because anyone can do it. And I think the other element is actually, can you, in a very specific domain, drive a flywheel of data capture? So if you're a startup, you don't need a team of 100 engineers anymore. You can do something with 10. And can you start to incrementally take out chunks of incumbents? I think that's how you want to wedge your way in. And if you're an incumbent, I think you're really thinking about, how do I manage my own kind of data to get on this flywheel of innovation?
Yeah, which has kind of been true for all AI systems for as long as they've been. It's just the next generation of them, same problem, next generation of startups tackling it and incumbents trying to leverage what they've got.
Yeah, exactly. And I think you can have an extreme case maybe where you can drive a lot more value from a much smaller team. There's this idea of like one man sort of decacorns. Yeah, exactly. Like I like the idea of that. This is the reason I'm doing my side hustles, you know.
Well, I look forward to you being the first one-man decacorn. I mean, it's actually interesting. I wonder if you could be a one-man decacorn. Obviously, there's some ifs in that. Like, what if that helps like places like the UK where you might get one or two brilliant people, but getting all the talent is sometimes harder than, say, if you're in Silicon Valley. If it's a case that you only need one or two or three people to build, and you've got all the right people, then potentially it gives an opportunity for the UK or places in Europe to be the first decacorn founder from a single.
Yeah, I think on that front it does. I think there's a cultural challenge still.
Lots of other challenges, but one of the big challenges has been building teams, right? And exited talent who've already built things and hiring people who've already scaled things is a little bit harder in London than it is, say, in the Valley. But if actually you need fewer people to achieve the same result, then maybe it removes that one complexity to building in the UK. Yeah,
I think that's true. I think the big, I guess, the cultural one aspect is actually more on the buyer side. So you still need people to take risks, and that risk-taking attitude from incumbents or enterprise just exists more on the, I think, still on the other side of the Atlantic. But
well, there's lots of other challenges to solve. Speaking of kind of Silicon Valley, seems like the rise of hardware is back. We seem to be enjoying that one from our investments. What are you most excited about from a kind of hardware perspective?
I think, I guess kind of at a meta level, it's just quite exciting, as you say, to go back to the roots of what kind of started all of this. If you think about, the last, I'll probably get my decades wrong, but like the last 20 plus years, like it's built on the fact that we can just shrink our transistors and and we can get better and better software. We can essentially fit more and more longer code bases and run them just as efficiently. And I think that unleashed, so much value for everyone. But it was built on fundamentally hardware innovations which I think require a certain level of risk tolerance that maybe VCs have strayed away from. In some ways, they've sought and got used to easier returns. And I think it's a really interesting time to be looking at that space again. I think we're not going to get AI ubiquity. We're not going to get this kind of AI first world without these fundamental innovations at the hardware level. And I think it's a challenge to invest at that stage, but I think the opportunities are massive if you can do it.
It's exciting for us now because, investing in semiconductors, 7-8 years ago, no one would touch them because software was eating the world and hardware was keeping up with software. So why spend a lot more money on the hardware? We were starting doing it from the UCL Tech Fund. We did 2016 our first semiconductor investment. And it was just a desert for capital back then, like so hard to find people who wanted to invest in semiconductors. And suddenly it's a fashion again, which is very exciting.
You must be excited, particularly. I was still in undergrad, so.
Yes, those of us who are a little bit older than you are experiencing like the uptick in semiconductor and hardware, and it's it was such a neglected area of compute. Like just no one wanted to touch it, and it seems like the world's woken up and gone like, oh, we should have been investing in we should be investing in the next generation, not just iterative process here. But the Moore's law was so alluring and so powerful that people didn't need to. But so for us as investors, it just opens up a whole lot of opportunities. And the UK's got a load of strength. ARM being a huge win here, and lots of photonic strength and other bits and pieces.
Yep. I think it also ties into those meta trends, right, of scale and size of our models. And what I meant by when you think about these big trends, how do you think about like the second order investments that come out of them? So we have a big focus on future compute where that to me means how do you enable this AI paradigm shift, and that has everything from novel memory to so that you can compute and store memory in the same space and drive efficiencies there. How do you connect up more and more processors? How do you make sure that the data on edge is getting to our data centers to begin with? I think there's a whole world of opportunities there.
Well, and beyond that, so you've got that, then you've got how do you create enough power? Is it just buying up nuclear power stations in the US, or is there another solution in the long term? How do you get that power to the data centers? How do you ensure that the data centers are backups are going to be there in case there are problems with the power? How do you, there's a whole new wave of technology just to support this one kind of massive mega trend. And so looking all the way down that stack and finding areas of opportunity across the full stack of from creating the electrons that are going to power processors through to the processors themselves, moving bits around.
Yeah, and I think that ties into the other trend that we speak about a lot, which is climate tech, right? The reality is and there's always this, I think, interesting dilemma, if you like, where there's an argument to say, as we were touching on before, that AI could radically accelerate innovations and discoveries across a range of fields, which actually could help the climate battle that we're facing. But so far to get there, we're having to drive energy usage.
Yeah, we have a chicken and egg problem.
Yeah, and so that ties into then, where are we actually getting renewable energy from? How do we drive renewable energy through? How does that relate to our grid stability? And I think it's just interesting to see how investment and VCs and deep tech investors have to kind of solve that chicken and egg problem by underwriting one or two of those risks. And I think that's true VC investing, if you like. And that's going back to the hardware comment, right? Like, how do we get back to the basis of and the root and fundamentals of what it meant to be a VC early days?
And the rewards are massive. If you can solve the problem for networking a data center or for getting the power to a data center correctly and efficiently, then these are huge problems that humanity is facing. Mm-hmm. And it's prepared. It's good. That's where the value is going to flow. So for us as VC investors, there's a lot of risk in there, but the rewards on the other side are huge. Mm-hmm. So it's worth taking those bets, even if for a while they were very unfashionable.
I'm again not envious of the fact that I don't think I quite had much experience during that period.
You'll get there. The cycles go round and round. You'll go through your own winters.
And I think the other interesting, I guess, trend that's come out of this a little bit, or something I think quite a lot about, is if you go through it, speaking of cycles, you think about kind of the most valued jobs in society. We went from physical, real world occupations to the knowledge economy, and now arguably that's the thing being taken first. I think a lot about how you can utilize AI, and I think this is, again, going back to the start, for startups, how do you build for your domain? Mm-hmm. And LLMs are obviously built in the kind of knowledge space rather than the physical world. And I think the opportunities there are being aggressively funded, and they're kind of eating into some of these kind of larger enterprise spaces. But actually what that means for real world activities, and the fact that that's still kind of white space that hasn't quite been cracked, is an interesting kind of speaks to robotics and all these other interesting kind of trends.
It's interesting to see how much robotics will play into the kind of physical world. And currently, the blue collar market for labor, whether so the sort of first wave of automation has happened, right? Mm-hmm. So your car factories have 10x fewer people on the floor. I think they now have people in more highly skilled, more interesting jobs in general, which I think is a good thing. Will we see that for the jobs which are much harder to automate? And that's the challenge I think we're seeing in the robotics world right now, is just going right back to when you're talking about out of distribution generalization, or AI dealing with context it's not been trained on. That's what we're trying to solve. On the software level, there's also a load of hardware issues with having a robot that works and works as well as a human, because it needs to work in a human-centric world.
I think there's this, again, a chicken and egg problem where you spoke about how people are doing more over time more interesting jobs, maybe where they're looking after the machinery that's now doing the automation. How you actually get to a point where we're able to manufacture the actual hardware at a cost that makes it make sense to offer robotics on scale. And I think that speaks to this idea of humanoid form factors versus other form factors. But the reality is that if you think about how many degrees of freedom your body has to be able to function in the kind of flexible way it does, it opens up lots of vectors for breaking. So you almost want robots to fix robots in which is a kind of...
It does feel like there's a tipping point. And I don't think I know when this is coming, but there's a tipping point where you say when manufacturing of humanoid robots that have enough flexibility and ability to cope in a human environment gets to a point where they are sort of beginning to commoditize. Mm-hmm. That's going to open up a huge amount of opportunity. In the same way LLMs have opened up opportunities in the knowledge economy, that's kind of the tipping point that opens up a huge amount in the robotics sort of second order level of jobs and tasks.
Yeah, it's true. And I think the reason, the kind of, I guess, philosophical argument for humanoid form factors is the world is built for humans. And so if you can just fit that form, you can hopefully scale the manufacturing such that you can drop it. And then it acts as a platform that allows you to just switch into our kind of software first or AI first world, to just kind of be able to utilize that platform for specific applications.
And we'd expect ultimately the humanoid robot to be relatively commoditized, and it be in the AI and the task ability to complete certain functions within the world that you're trying to drive the value through. Is how you see it playing out?
I think so, yeah. It's that one open question is just, embodied intelligence is around, you are in some ways intelligent because of you're constrained by and defined by the actions you can take in the world. And so, maybe, like I say, to get to the level of kind of dexterity that humans have, there must be some sweet spot, right? I don't know that you're going to get a robot that's quite necessarily as dexterous, just because it opens up so many points of failure that requires so much ongoing maintenance. But I think directionally, that you're going to find some sweet spot there. And then it's, I think, a question of it's a software question around how do you actually place them. I still sometimes think it will be creepy to like open a door and see a massive humanoid robot in your face. But I
mean, yeah, there are enough iRobots and other films to sort of scare us along that line. That we've got to be very sensitive and intelligent in the way that we build the software and even the hardware around that one.
Yeah, I think my 2-bedroom flat's already small enough without a massive 6-foot robot standing. So yeah, maybe it can like curl up in a ball, but that's kind of creepy as well. So I don't know. Yeah,
I think you're going to have to get over the creepy factor. If you do want a robot made, you're going to have to get over the creepy factor. And what are we most excited about for next year? Like, what are we seeing coming, do you think?
I think my kind of what I'm tracking most, I guess, with most interest is kind of that question of reasoning. Yeah, I think I work with LLMs all the time within Albion, and I've seen the progress it's making. I don't think there's any argument there. I do still think, like I say, in non-trivial, complex, ill-defined tasks, so long time horizons, abstract reward spaces, it's not zero shot. But I think we're getting there, and I think it's an interesting convergence of ideas around reinforcement learning and things like that should combine to be able to do that. I think there's interesting perspectives on new architectures that are coming out all the time.
For me, a lot of it is in the kind of the new compute world. Like, how are we going to move beyond Van Neumann architecture? There's loads of interesting stuff, loads of everything from optical compute and people doing compute with optical fibers through novel forms of memory, as you were saying, and then very specific chips architected just for transformer models and all this stuff. And it's really interesting to see how that plays out. I think there's still loads of innovation coming over the next year or two that will change the way that we compute. And so I think that's an area, for me, that's the area I'm probably most excited about, is which bits are going to play out, how is new compute going to be architected? Because at the moment it feels like GPUs have filled an amazing hole, and we've been very lucky that NVIDIA has been somewhat lucky that they filled a perfect hole in AI. We're still running on CPUs and Van Neumann architecture for a hell of a lot of other stuff. That stack in 30 years' time is going to look completely different. I'm just fascinated to see which bits of the world that we're seeing being built now. It reminds me a little bit of you look back at in the 40s when people were developing computers and trying to work out valve computes and transistors, and you can go to the computing museum up in Bletchley and see all the different attempts to build next layer of compute. It feels a little bit like that at the moment. The sort of world has woken up to compute again, and everyone's having a go at building the next bits of the architectures. Really, really exciting on that front.
I think it's an interesting the advantage NVIDIA has in some ways is it's amazing at vector matrix mults. And so because that's the dominant paradigm, you build for that paradigm, and that provides opportunities and it creates the scale we've seen, but it also can sometimes constrain a little bit of innovation. It's a trade-off that I think will be interesting to track.
I'm interested to see. NVIDIA are in such a good position to maintain that as well. The whole CUDA world keeps them nicely afloat and ahead of competition. It's very hard to crack that. So whether it's people working with NVIDIA or trying to disrupt small parts of NVIDIA, or how they take on that giant right now is again fascinating.
I think I'm fairly confident that even if we get new architectures like state space models and different things, they're fundamentally going to be relying on these kind of large matrix multiplications. So I think GPUs will be here for specific architectures. I think that's very interesting, right? Can you build 4 transformers for inference? And then it's a bet on, as a founder put it, that transformers are the end of history. Can you? And that then speaks to that same idea around, actually it's maybe less about the architecture, more about the data. So if you do stumble on a architecture that works really well across a lot of use cases, then maybe it is less and less about trying to build new ones and more about the data. Or alternatively, maybe it means that there's a better one out there that is more data efficient. And I think the truth is our models aren't very data efficient. I think the other area that's interesting is this idea of how do you allow the model to, and this again speaks to this kind of continuous learning theme, but select its own data and continuously learn. So you're more sample efficient.
And what about, we're seeing some quite fun medtech stuff at the moment. I know you're working on an ultrasound one for depression. How do you see that world playing out over the next 5-10 years?
I think
neuromodulation of itself is just super fascinating to me.
I think of all the, this is going to be a relatively basic argument, but like I don't like the idea of having my head cut open, and I don't
understandably. Neither do we.
and I think the blood-brain barrier has posed a huge amount of challenges for us, and I think our ability to be able to really specifically modulate parts of our brain and is an interesting way around a lot of these issues. So, whether that be how do you get a better understanding of brain regions associated with depression, how do you actually allow for an ongoing kind of neuromodulation of that so that you're not maybe as dependent on pharmaceuticals, or for people that are treatment resistant, they have a new kind of opportunity, or can you start thinking about how you can very specifically, for lack of a better word, burn a tumor away without having to cut through. Those are all fascinating things, I think, and then on the extreme you have the kind of Neuralinks, which I think, directionally again is very interesting. I don't know how close we are to
feels a long way away before we're
but I would like to download French or something into my head. That would
Matrix style.
I'm not very good at languages, and so that would be really good.
Did you get that 1999 film reference?
Yeah, I watched Matrix.
Okay, good.
But yeah, so I think that's that kind of area of neurotech I think is really interesting. And going the other way as well is potentially quite interesting when you combine that with ideas around AR and VR, and our kind of next platform, our platform shift of the future. There's potential synergies there that are, again, not necessarily in the immediate term, but you can see how these things can fit together over time.
Yeah, lots of hardware there too to sort of make it work. Still feels quite clunky on the hardware side.
Yeah, and some of that's batteries, which is another area of interest. And some of it's memory, some of it's processing. There's lots of cool untapped areas. Yeah,
which is what makes our job fun, I guess.
Yeah.
The Tough Tech conference over in New York or Boston last week, and people are still I was worried that quantum might be hitting a bit of a winter, and it shouldn't do, because actually you're seeing some very steady, systematic progress from the leading quantum players. I think there's a lot to be excited about there, and I was in with IBM looking at what they're doing last week too, and that was really cool, and it gave me a bit of confidence. But I thought the world had gone slightly cold because it hadn't gone super inflected at this point. But
what do you think the first kind of use case or application will be?
So I think it will be in materials modeling and simulation, and I think in particular it will be in things that you can model a very small part of and then understand the bulk. So that would naturally be things like crystalline materials, and the reason I think that is you can simplify the problems spaced down quite small, and so even if you've got a quantum computer which is still small numbers of qubits and low fidelity, you still can perform enough calculation before you decohere that you can model a very small area. And so things like, can you have new battery materials which are likely to be crystalline or photovoltaic? That area is really fascinating to me, and I think that's kind of graspable with near-term quantum compute. Like even now, I think possible. I'm on the board of Phasecraft, and that's the problem they're really close to working on. So I think those are the areas you're going to see, and then it'll extend out from the very easiest, the simplest problems, or the ones that are most suited to small areas, small spaces that you can compute and then scale out. And as they get slightly more sophisticated, you'll be able to do more complex materials, to the point where then you're simulating things like drug-drug interactions and the bits and pieces where quantum could get really, really interesting for medicine. I think it's a long way away before we're doing sort of generalized compute and just popping in for a quantum answer for something that's too hard for classical. But in the next 10 years, I think we'll start to see scientific breakthroughs powered by quantum.
You see a world where you accelerate or quantum and our kind of AI developments actually play well together, or do you think they are directly competitive?
No. I think they're complementary. I think there are some things that AI is very suited for, and there are a lot of tasks. In order to use these quantum computers that are imperfect, there is going to be a lot of handing back to classical compute, and therefore handing back to kind of artificially intelligent compute that you can do a lot more crunching of the numbers with, and handing back just a very slithers of a problem that would take an exponential amount of time to solve on a classical computer. So I think those two are going to play in quite well. And so I think they're probably, you've still seen quite a lot of materials discovery in the AI space, and I think it's absolutely complementary to quantum materials discovery. I think those two things are going to quite important to work together to actually get any real results. As we sign off, I think it's important to say that if you did like this, please follow me on LinkedIn, because I'm currently behind Seb in numbers, and he's giving me a hard time.
For obvious reasons.
And so, if you would like to follow me rather than Seb post this discussion, then I'd be very happy.
Yeah, like and subscribe. And if we get 1,000 likes, we'll do this first series. And also, I'm obviously the more charismatic one, so don't follow him on LinkedIn.
Thanks.